Bahrain is developing at breakneck speed. This development has given rise to a rapid increase in vehicle ownership and use, especially in the capital Manama, where over 160,000 vehicles per day make use of the King Faisal Highway. Moreover, along its route, many new mega developments are taking shape, with their approaching launch dates creating a dilemma for those entrusted with keeping the vital road infrastructure at a state where it can cope with these accelerated demands. The Ministry of Works has already overseen the construction and ongoing maintenance of over 7,000 lane kilometers of roads in Bahrain.
The starting point for the current development going ahead in the Kingdom of Bahrain in terms of roads network development was in the year 2003. This is when the Ministry of Works embarked on a very ambitious plan to upgrade the whole network. The outcome of this exercise came out in the year 2005 with the Bahrain Transport Model and the Strategic Master Plan for roads. It's very important to realize that in Bahrain we have major arteries that serve the major population of the kingdom. The two most important ones are the southern corridor, which is the Sheikh Isa bin Salman Highway, and the northern western corridor, which is the King Faisal Sheikh Khalifa bin Salman Highway. On the southern corridor, the junctions that were upgraded from at-grade junctions into grade-separated interchanges were basically the replacement of the Sitra bridges, the Al Hassan interchange, the Bahrain Map interchange, and the Isa Town Gate interchange. This facilitated a free flow of traffic all the way from the King Fahd Causeway up to the Sheikh Khalifa Port, the Mina Salman Industrial Area and the Sheikh Salman Industrial Area. With the current project going on at Mina Salman interchange, creating again a grade separated interchange, there will be completely free flow all the way from the east to the west. There will be a new north corridor that's being planned for the north coast that will be extending from the east, from the King Hamad Medical Complex and the new expansion of the airport, to the west to the north town. The North Manama Causeway is basically a link, the first phase of the link that connects the current network at Al Fatah Highway and King Faisal Highway to this new planned corridor.
At an estimated cost of 98 million Bahraini dinars, the North Manama Causeway spans most of the northern coast of Bahrain's main island. It measures 4 kilometers of new roads and more than 3 kilometers of bridge structures. It will not only provide the connection with the new developments, but also be a catalyst for continued future progress. In this film, we'll examine the North Manama Causeway's innovative precast segmental balanced cantilever construction method and show some of its advantages. We will also outline some of the engineering challenges it presents.
In our project, we are using two different methods to erect the segment. In the ramps, we are using a crawler crane, and in the bridge too, we are using a launching girder. In the board situation, a shoring tower are installed around the piers.
The construction sequence includes the piles, the pile cap, the pier, the bearings, and the precast segments. The foundation of the causeway is made of board and cast-in-place concrete piles. These piles are formed by drilling a long shaft in the ground up to a specific depth and diameter given by the design. A steel reinforcement cage is then lowered inside the shaft, which is then filled with concrete. A number of piles form a pile group connected by a pile cap. This pile cap then serves as a rigid foundation for the bridge structure and to distribute the bearing load from the piers to the piles. Each pile cap carries one or more reinforced concrete piers. These piers serve as the main support for the bridge, upon which the bridge superstructure rests. The pier will serve as the mounting platform for the precast segments. However, before mounting the precast segments, bearings are fixed into place on top of a pier. The bearing allows the segments to accommodate expansion and contraction under high pressure and enable segments to withstand rotation and translation movements around as determined by design. Bearings are designed and custom-made according to the requirements of the bridge. A segmental bridge involves building short sections or precast segments one piece at a time, as opposed to traditional methods that build a bridge in very large sections. These concrete segments are constructed on the ground in a precast yard before they are transported and hoisted into place. The short line casting method is used to match cast all the segments required in the bridge. Through this method, each segment is cast in a stationary steel mould and against the previously cast and hardened segment. The freshly cast segment, called the wet cast segment, is moved after 10 hours into the match cast position. This way, all joints will perfectly match when the same segment is erected in the same sequence in the final structure. The match cast segment is then brought to the transfer area on the manipulator. And transferred the next day to the storage area. During erection of a segment about a supporting pier, it is lifted into position and the adjoining match cast faces are coated with epoxy. Temporary post-tensioning bars are also installed and stressed to attach the segment to the cantilever. After a new balancing segment is in place on each end of the cantilever, post-tensioning tendons are installed and stressed from one segment of one end of the cantilever to its balancing mirror segment on the other side of the cantilever. Consequently, as segments are added, more cantilever tendons are added. Upon completion of a cantilever, with all the segments symmetrically fitted into place, a link slab is cast at mid-span to connect subsequent cantilevers and form a complete span. Completed cantilevers are connected to one another in their respective closure joints.
There are several advantages in working with this kind of technique, using a launching girder for the erection of viaducts. The main one, in my opinion, being that it will reduce quite a lot the interface with the traffic, especially in crowded areas like, for example, the junctions that we have here with King Faisal Highway and Sheikh Hamad Highway. The other big advantage is, of course, the speed of erection of the bridge's deck, considering that the segments are precast in our precast area. Obviously, it will reduce the time that we need to assemble the segments here on site. Another big advantage is that it will reduce quite a lot the safety exposure of our people, since the number of people that are working on the erection is much reduced, considering that most of the manpower is shifted to the precast yard.
The short line method is very beneficial in balanced cantilever construction because it provides a system for gauging exactness or detecting errors in the proportions and measurements in the construction of individual segments. The method offers room for adjustments and corrections on site, ensures longevity of structure, and guarantees a cost-effective solution as well as the speed of construction.
The traffic management is divided into 9 stages. Starts with stage TM1, we call it, and ends up with TM9. This consisted of building roads outside the existing roads of Al Fatih Highway, We built new roads there and we diverted the traffic on the new roads, and the existing Al-Fatih road was closed for the piers, the piles, and mainly the construction of the bridge.
In coordination with Haider Consultant, the design consultant, Six Construct implements an internationally approved safety, health, environmental and quality management system. Haider Consultant is also responsible for overseeing the quality control of all phases of construction. This process includes continuous on-site testing of fresh concrete and soil compaction, as well as testing of material properties at specialized third-party laboratories. Each construction material is tested according to predetermined testing plans and standards, so as to verify the properties are intended and specified in the design. Traceability is key to maintaining control over quality throughout the construction process and assure compliance to the specifications.
In terms of the quality, we are working closely with the contractor and reporting it to the client itself. We are maintaining a high quality standard of this prestigious project. And this is one of the most prestigious projects and probably the biggest at the moment in Bahrain.
Testing of bearing components, which are vital for maintaining the balance and durability of the bridge structure, are conducted in Italy and are subjected to further tests by other quality control institutions. An environmental management plan is also implemented, which incorporates the principle of sustainable development. This includes minimizing noise generated during construction, water testing or spill control for activities in the adjacent marine areas, and control of dust on site. Six Construct also conducts a monthly progress meeting, which is participated in by all parties of the project: the Ministry of Works, the consultant and the contractor.
The North Manama Causeway acts as the first link to the new North Corridor that is being planned on the north of the kingdom, linking the expansion of the airport, the King Hamad Medical Complex on the east to the North Town at the west. In short, I can tell you that with the current projects that has been done and is being done at the Ministry of Works, the future of roads in Bahrain is very bright.
An innovative construction method aimed with a greater vision now brings a new solution to traffic congestion problems in the capital and largest city of Bahrain. A strategic road development in line with Bahrain's Vision 2030 for the overall improvement of transport infrastructure and roads network. A bridge setting new milestones and propelling Bahrain towards a brighter future.